Welcome to the JSLint, the Good and Bad Parts course for Pluralsight. My name is Todd Gentili. When using JSLint, you will undoubtedly wonder why certain seemingly normal and acceptable language constructs are resulting in warnings. This course is going to look at 5 JSLint checks that I think are worth further exploration. I'm not going to blindly suggest you follow all of Douglas Crockford's advice, but I am going to suggest you carefully consider before turning off the options that you don't like. This course is designed for a programmer that already knows enough JavaScript to create functioning code. I also assume you know how to run JSLint against your code. It's not important if JavaScript is the only language you know. However, if you're relatively new to JavaScript but well studied in a classical inheritance language like C++, C#, or Java, you will likely find some surprises in this course. Some warnings issued by JSLint serve as the equivalent of compiler errors. Others are more oriented towards helping you avoid unintended behaviors and traps in the language. Others struck me as little more than preferences for a certain coding style or formatting approach, and some just left me scratching my head. I will cover 5 practices that JSLint wants you to avoid. They are: declaring variables close to their first use. This is actually much more than a coding style issue and has to do with how JavaScript hoists variables. The next one is, in addition to knowing to use strict, you have to know where to put it and a convenient way to put it there. Why the block brace layout isn't just a silly formatting issue, and the heretical suggestion that you should stop using the increment and decrement operators, both the pre and post forms. And one I'm still on the fence about, not using the continue statement. JavaScript has function scope, not block scope. This is an important distinction. C programmers will not find this surprising, but C++ programmers have all but forgotten that C used to require something similar. Let's switch over to Visual Studio and see what's going on under the hood. This is an innocent enough looking piece of code. We've got useStrict up here at the top. We declare a global variable and we have just one method. Let's just hit save on this and we'll let JSLint run, and it comes up with 5 warnings and 4 messages. So the first thing it doesn't like, and there's actually an error, and that's this line. We forgot to put var in here. So what's going to happen here is we're going to potentially clobber a global variable, but this max arg is going to end up in the global space. So we want to have a var there. The second thing it doesn't like is we start a for statement and then we declare another variable down here. So what it's really doing behind the scenes is it's creating a var for us up here and it's assigning it to undefined, like this. So then it sees the redundant var, it ignores it, and it assigns I to 0. So we might as well declare the var up here, and I know this will seem strange, but get it out of the for statement because it's misleading. The I is not in scope in just the for statement. It's in scope for the whole method. And there's one other thing it doesn't like. We're not even close to getting rid of the warnings. It really prefers the syntax of putting a comma here and then getting rid of the extra var keywords. So it wants to see your code look more like this. So there we have it. And now let's save off, and we can see we've only got 2 warnings left. So let's go back to the PowerPoint presentation. If you have a lot of functions, it's going to seem ridiculous to put a useStrict inside every function. The trick here is to have only a single function per file. This is more important than it might appear. Tools that combine multiple JavaScript files to limit the number of HTTP requests can change your program behavior depending on whether the first file specifies useStrict or not. Creating a single function is quite easy to do in JavaScript. Use the immediately invocable function expression. Let's go back to Visual Studio and see how that's done. So we're just going to put the function up here, and we want to avoid putting the function keyword in the statement position. So we add this opening parentheses, and then we put function, and we put our 2 parameters, and let's just delete that closing bracket for now. And then we come down to the bottom, and if you had multiples, you go all the way to the bottom, and then you close that off. Then you invoke it, and then you add that closing parenthesis, and then you put a semicolon. And now let's save that. Oh, and we forgot to do one thing. And the whole point here is to take that useStrict now and just move it down to here. Now when we save, we can see all that's left is some strange message about ++. Normally, I'm not one to weigh in on formatting issues. I think programmers should format their code however they like to read it. IDEs are extremely fast at reformatting code. However, in JavaScript, we have to worry about semicolon insertion. It's best to see this in action. So here we're in a new blockbracing.js file, and it contains 3 functions, but the 2 we're interested in are these top 2. One that starts here, called block braces, returns or tries to return a simple JSON literal object here. And it has a break before the brace. So instead of having it right aligned, it's doing block bracing right here. So down below, we have right braces, which leaves the brace on this line on the right-hand side. And the surprising behavior is these behave differently. What JavaScript really does is it ends up putting a semicolon right here. So it returns undefined. Whereas with the right braces, it does not insert the semicolon, so it returns the correct object. And then this third function just is a little test to see the results happen. So block bracing can hurt you, right bracing can't. I suggest you use right bracing. If your immediate reaction to this slide was visceral outrage, then this topic is especially for you. While I would never suggest there's anything wrong with the innocent use of the pre-increment operator, the argument is that it's just a siren song, luring the programmer into bad practices. If you have the discipline to resist the song and stick with single standalone uses of the pre-increment or pre-decrement operator, you can skip this topic. If, on the other hand, you do a survey of your code and you start to find uses like the second example, which is C++ and not JavaScript, give me one more minute. Again, this isn't too terrible, but in my mind, it would benefit from being on 2 lines, and I have no idea why I wrote it this way. Now, I know the third example has been around forever and can be considered an idiom or even canonical, and I always have 1 or 2 C++ students in my classes whose eyes light up when they get it. It's really just trying too hard to be cute. This is when things are really getting on down the road to harder to read and harder to maintain. I always program first to make things work, but the longer I program, the harder I work on making my code readable and maintainable. I'm starting to come around to see Douglas Crockford's point on this, and as he says, he's really only asking you to type in 1 more character. For the moment, let's humor him and see what happens. So here we are in Visual Studio, and down below you can see the JSLint error and the highlighted line that's using the pre-increment operator. Let's go ahead and try and do this. So we can just say I plus equals 1, and then I'm just going to reformat to get the proper spacing. And that's it. I'm thinking maybe we can do this. The continue statement. This seems like it would be an easier pill to swallow, but I'm still on the fence about this one. I was taught a long time ago that every function should have 1 entry point and 1 exit point. Looping constructs should be written such that the flow of control is not interrupted by continue or break statements. In recent years, I've come to believe that in certain circumstances, this was bad advice. I'm finding that disciplined use of return and continue statements, mostly in the form of guard clauses at the beginning of methods or loops, can actually enhance the readability of my code. Seeing a guard clause at the top and recognizing it for what it is allows my mind to then disregard it for the remainder of the method. When I instead treat the conditional as an entry point to an indented level of my code, my mind tends to keep track of the multiple levels of indentation. Still, I'm willing to keep an open mind. Let's look at an example in code. So down below, we can see the JSLint errors that are getting created from the use of the continue. The second error is actually a false positive. But let's go up and let's make the change that JSLint is looking for. Instead of having negated logic here and then continuing, this is my idea of a guard clause. It's basically saying, hey, there's a certain condition that I want to look out for, and if that condition happens, I just want to continue. So instead, what I'm going to do is just make sure that this property we're looking at does satisfy this has-own property. So then we're just going to indent the level of the code here. So then we kind of have to go down to the bottom, kind of make sure we get it in the right spot, which isn't too hard in modern IDEs because they highlight the braces. And then typically you want to just make sure everything reformatted. And that's it. So now everything's an indentation level deeper, but that's all that was required. Let's go ahead and save. And we can see both errors have now gone away. In summary, let me leave you with the 4 goals Douglas Crockford wants you to have when writing code. I hope you've enjoyed this course and have learned to get along with JSLint a little better. Thank you for watching.